You know, no matter what route we take, our pilot and the control centers on the ground are making sure we're safe in the skies.
Would you like something to drink?
Yes, thanks. Water would be great.
Thank you.
Thank you. Speaking of safety, we learned earlier that the FAA is always searching for new technologies and ways to maintain and improve the safety of air travel. That's where NASA comes in. Jennifer and I recently visited the NASA Langley Research Center in Hampton, Virginia, to learn about NASA's aviation safety program and the math, science, and technology they use in their everyday work.
How will NASA contribute to airplane safety in the future? How do NASA engineers use math in their wind tunnel tests?
What happens to an airplane when the angle of attack becomes too great?
NASA's aviation safety program is designed to make sure that airplanes remain a safe form of transportation for all future air travelers. Many pilots and engineers like me are studying new ways to prevent accidents from occurring. We are also looking at ways to provide new ideas and technologies to airplane manufacturers and airlines so they can keep our skies safe.
Well, isn't flying already safe?
Absolutely, Dan. Flying is the safest mode of transportation, and passenger safety is the most important requirement for air travel. But you see, within the next 10 years, it is expected that close to 3 million people will be flying every day. That's about 1 million more than today. With these numbers, more airplanes will be flying in our skies in many types of flight conditions. NASA is working to make sure that even with that increase in air traffic, airplanes will remain a safe and efficient way for people to travel.
Well, how do you do that?
One way is to make sure that all airline pilots have the necessary training to maintain control of their airplane and safely maneuver them during all flight conditions. It's my job to predict how well airplanes can be controlled in these different conditions.
How can you predict what an airplane will do?
We use a wind tunnel and model of an airplane. A wind tunnel is a facility that blows air over a model at different speeds and angles to simulate the airplane flying through the air. You see, testing full-size airplanes is too expensive, so we use scale models. This model is 1/30th the size of the real airplane.
1/30th? Hey, that's a ratio. A ratio is a fraction used to compare the size of two numbers to each other. The ratio 1/30th means that this model is about 30 times smaller than the real airplane. Right, John?
That's right, Jennifer. And we use a wind tunnel to test the model in conditions that are too dangerous to test on the real airplane. When we run the wind tunnel at different airspeeds, we move the model so that the wind hits it at various angles, like this. One very important angle we look at is called the angle of attack. Let me explain. When an airplane is flying through the air, the combination of airspeed and the angle of attack produces lift, a force which holds the airplane in the air. In normal flight, as the angle of attack becomes greater, the lift increases. If you have ever held your hand out of the window of a moving car, you can feel this lift as you move your hand. However, if the angle of attack becomes too great, the air no longer flows smoothly over the wing, causing a condition known as aerodynamic stall, and the lift will decrease. Now, although this flight condition rarely occurs, the airplane's controls may not be effective, and the pilot may not be able to safely maneuver the airplane.
But John, how do you know that the real airplane is going to behave the same way that the model does in the wind tunnel?
Great question. We use math to predict how the real airplane will behave under the same conditions tested in the wind tunnel. Let me show you. During wind tunnel testing, a computer system electronically measures the lift. The computer also determines the speed of the moving air, the density of the air, and the area of the airplane's wing. Using this ratio, we can compute the lift coefficient, a number that tells engineers like me how the shape of the model, position of the model, and the airflow around the model affect lift. Next, we create a graph that allows us to see the relationship between the lift coefficient and the angle of attack we have simulated in the tunnel. Because this graph is the same for both the model and the full-size airplane, we can predict how the real airplane will fly. So let's put the data on the graph and interpret it. During normal flight conditions, the lift coefficient increases as the angle of attack increases. The pilot should have no trouble controlling the plane. However, if the angle of attack becomes so great that stall occurs, the lift coefficient decreases, and the airplane may be difficult to control. From this graph, we can determine how the airplane will respond in different flight conditions. Knowing this information allows us to find ways to help pilots prevent or avoid entering unsafe conditions and to make the airplane easier to fly.
So, once you've tested the model and determined how the real plane will behave, how do you make sure the pilots are trained in these situations?
Today's airline pilots are highly trained using very sophisticated devices known as flight simulators. The simulator looks and feels just like a real airplane from takeoff through landing, and it allows pilots to practice many different flying procedures that they may encounter during a real flight. All of the graphs created from the wind tunnel test are given to people whose job it is to input these data into the flight simulator, making pilots feel like they're flying a real airplane. The simulator is designed to respond like the real airplane that has accidentally entered unsafe flight conditions, like the ones we've tested in the wind tunnel. Using simulators, pilots are especially trained to prevent loss of control and learn how to operate the airplane under conditions that would normally not be safe in a real airplane. This training will help to ensure that air travel remains safe for everyone. In fact, many of today's students who are interested in becoming airline pilots will be trained in simulators that use the research we are conducting here at NASA. The goal of NASA's aviation safety program is to prevent accidents from occurring and for all future air travelers to know they will safely reach their destination.
Thanks, John. You know, it's really
Hey, Jen,
cool that...
check it out. It's Colorado.
It sure is, Dan. Like I was saying, it's really cool how NASA is testing models in wind tunnels and then using technology to help pilots fly safely. And speaking of technology, Dan, didn't you find a really cool CD that takes you on an airplane's journey from gate to gate?
I sure did. This CD-ROM lets you meet some of the people who operate the air traffic control system. Join me next in Dan's domain and I'll show you some of the tools they use.